When the two gases are mixed, a spark will cause them to react. The atoms explosively combine as a pair of electrons become shared between each oxygen and two hydrogen atoms. A closer inspection of the inside of the container shows water vapor condensed on the cool container walls.
So let's take a look at the reaction of hydrogen and oxygen. My hearing is bad enough, so I'm going to put these on, just so I don't have to hold my fingers in my ear. There's a seal to keep the hydrogen in, and actually I filled it from the bottom, so there's a little opening on the bottom. I'm going to take that off. And now, on the top here, I have an opening. If I light this, let's light this baby. What happened? What do you think was going to happen? What do you think was going to happen? Well, you've seen the hydrogen-oxygen reaction before. But remember that in order for hydrogen and oxygen to react together, we got to have both hydrogen and oxygen. If I have a can filled with hydrogen without oxygen, we can't have a reaction. I only get a reaction where the hydrogen escapes from the can. As the hydrogen was escaping out the top of the can, what was going in the bottom to replace it? Well, air, and that air contains oxygen. So as the concentration of hydrogen in the can was going down, the concentration of oxygen in the can was going up, and eventually we reached a point called the explosion limit. And when the ratio of hydrogen to oxygen got to a certain point, then the reaction between them occurred very rapidly, and we got the familiar combustion, the familiar explosion reaction. All right, so you just got your first lesson. The reaction rate, or the rate of a chemical reaction, is going to be dependent on the concentrations of the reactants. I only get a reaction where the hydrogen escapes from the